In this video, we are covering non-proportional relationships. Now, if you remember, we covered proportional relationships before, and what those are they're relationships that where the ratio of the two quantities, the y quantity or the dependent and the independent quantities, is always constant. So, in a non-proportional relationship, the relationship between the two quantities is not going to be constant. So non-constant. What does that mean? Well, it's going to make more sense once we show you a table. So a graph of a non-proportional relationship will not pass through the origin, or 0, 0. So not pass. And instead, the graph will cross the y-axis at a point known as the Y-intercept. So, when you're talking about tables, like a XY table, and you look at the different values like 1 and 1, 5, 2, 10, 3, 15, you'll notice that there is a ratio that's constant, like the y over x, 5 over 1 is 5, 10 over 2 is 5, 15 over 3 is 5 still. Whereas in a non-proportional relationship, you're going to have different ratios, or like your fractions, your y over x is not going to be equal to each other. It's easier to see non-proportional relationships on graphs. They talk about in a non-proportional relationship, the graph, the line does not pass through the origin. So in a graph like this, remember this is the origin right there, it's the center. So in a non-proportional relationship, if you have a line, it'll start looking like that. Notice it does not cross the origin, which is in the center. It starts off right there. This would be called the Y-intercept. So they have a question. What is, or what should be true about the x value of an ordered pair for a Y-intercept? Well, think about it. A Y-intercept, they call it a Y-intercept because it's when a line touches the y-axis. So if I have a graph right here, and I have a line that crosses the graph, let's say right up here, the Y-intercept is up there. If the line is over here, the Y-intercept over there. The line is like that, the Y-intercept is down there. What do we notice about the x value of such a place? Well, the x value is 0. It is always 0. Why is it always 0? Well, because Y-intercept means when this line right here, when this blue line, the one I drew, touches the y-axis. And at the y-axis, the x always equals 0. So let's go ahead and start some examples, and hopefully this will make more sense. In her search for a gym, Hillary found a location that charges $10 as a one-time sign-up fee. So that's something she has to pay at the beginning. And then $20 each month. Use the information to complete the following. Complete the table to show the relationship between the number of months at the gym and the total cost of the membership. So we're going to do some of this in our head. We're going to skip the 0 months because that can be kind of confusing for people. So at 1 month, how much has she spent on just the gym? Well, she has to pay $10 plus $20, so that's $30. And after 2 months, she's paid the $10 plus 20 plus 20, so that's $50. And at 3 months, she's paid $60 in monthly fees plus the $10 at the beginning. That's $70. And at 4 months, again, $20, $40, $60, $80 in the monthly fees plus the $10 in the beginning. So she's spent $90 on the gym so far. How much would she have spent at 0 months? Well, she has to pay $10 just to start, just to sign up. And how much would she pay for X? Well, the process can help us. How do we figure this out? Well, we just said 20 times the number of months. So remember, this is the X value. the independent variable, and this is the y value, the dependent variable. So 20 times x, so it's not just 20 times 1, because 20 times 1 does not equal 30. You had to add the $10 initial fee, the constant. So let's see if that's true. Oops. So this is 20 times 2. This would be, oh, sorry, that's not 20 times 2. It's 20 times 1. This over here would be 20 times 2, which equals 40, plus 10, 50. 20 times 3, which is 60, plus 10, which gives us 70. And 20 times 4, which gives us 80, plus 10, which is 90. So if our number of months was x, so you see how our number of months was 1, then 2, then 3, then 4. If it's x, then 20 times x plus 10. And notice I don't have to do parentheses if I'm multiplying a variable with a number. What should it be at 0? Let's see if this rule still applies. 20 times the number of months, which is 0, plus 10. 20 times 0 is 0, plus 10 does equal 10. So what does this equal? Well, this equals 20x plus 10. That would be the cost. So let's ask ourselves, is this proportional? It seems like it would be proportional because there's like a pattern, right? But remember, you can test the proportionality by putting y over x. So the y over the x. So remember, this is the y, and this is the x. So y over x over here would be 0 over, sorry, not 0, 10 over 0, which is undefined. So I guess we can't use that one. But how about this one? How about 30 over 1? What does that equal? Well, that equals 30. And this would be 50 over 2, which gets us 25. And then this is 70 over 3, which gets us some other ridiculous number. But notice 25 and 30, those are not equal. The y over x for with this data set is not equal, so this is not proportional. And that's how we test. We just do y over x of a couple different points. Proportionality is actually easy. Well, let's answer some questions. What is the slope or rate of change shown in the table? Well, the slope is what's being multiplied by the x. It's right over there. It's 20x. So our slope is 20. That's the rate of change because every month she spends an additional $20. What is the value of the y-intercept? The value of the y-intercept can be found here. Sorry, can be found here. So remember, when x is 0, that's how we find the y-intercept. So what is the value of the y-intercept? It's 10. So you can find the y-intercept right there. It is 10, or you can say, if you want to do an ordered pair, it would be x is 0, y is 10. And is the table proportional? Is it explained? And it is not. As we showed earlier, y over x is not constant. Or not equal to each other. That's what we mean by constant. All right, let's try this. Let's use the table and graph the relationship. So when x is 0, y is 10. So at 0 months, it's $10. And then at 1 month, it's 30. 1 month is 30. 2 months is 50. 3 months is 70. 4 months is 90. So on and so forth. Let's draw a straight line. Try to do it as straight as I could. There it is. What is the slope or rate of change for the line in the graph? Well, the slope, again, could be found change over y, change in x. So again, y over x, and or change in y over change in x, I guess. The y is not, if you count up, 1, 2, it's not actually 2. It's from 10 to 20 to 30, so that's actually 20. And the x is from here to here, which is just 1. That's just 1. So 20 over 1, which is just 20. which is the same thing as on the table. You just, in fact, it was easier to do it on the table. All right, let's look at the value of the y-intercept. Value of the y-intercept is right there. So you just have to, let's do a different color. Let's do blue. Y-intercept. The y-intercept is where the line touches the y-axis, which is this axis right here. Remember, this is the y-axis and that's the x-axis. So what's the value of the y-intercept? It's 10, or you can say that is 0.010. And finally, the graph proportional. It's no. Oh, I should have said no over here too. And how do you know? Well, for the graph, line doesn't pass origin. Based on the graph, you know it's not proportional because it does not run through 0.00, which is the origin. All right, let's take a look at proportionality and how it relates to equations. This is actually my favorite part. Write an equation to represent the relationship between x, the number of months at the gym, and y, the total cost of the gym membership. So, y is the total cost of the gym membership. Let's just say gym. Cost of gym is $20 times the number of months plus the $10 signing fee in the beginning. And remember, they say y is the gym membership and x is the number of months. So how do we rewrite this? Well, we say y equals 20 times x plus 10. So remember, you normally multiply the rate times x, which is your independent variable. And then in this case, we had to add 10 because that was the constant. So basically, we did this, except we wrote y equals this. Do you see the slope in the equation? I do. The slope is 20. Where is it? It is slope is multiplied. It's the coefficient with x. And guess what? That's always going to be the case. The slope is always going to be multiplied with the x. Do you see the y-intercept in the equation? Remember, the y-intercept is 10. I do. The y-intercept is right here. Yes, it is a constant. And it's being added. So, what conclusion can we make about non-proportional equations? They have a constant. And what is a constant? A constant is just a number without a variable. So proportional equations look like this. Y equals your slope times x. So that would be like y equals 5x. Whereas a non-proportional graph or equation is y equals mx plus some kind of number. So like y equals 5x plus 7 or something like that. And if you see this plus 7, if you see anything aside from the y equals something times the x, that means it's not proportional. So this is proportional, not prop. And this is not proportional over there. All right, so non-proportional equations, they will be written in the form of y equals mx plus b. This is very famous. You guys see this a bunch, where m is the slope or rate of change, and b is the y-intercept. All right, let's try some problems. For each equation, in 1 through 3, list the slope, the y-intercept, and whether or not it is proportional. Well, the slope, remember, the slope is attached to the x. So it's this. You may be thinking, is it 4 or negative 4? It's negative 4. The negative just tells us that it's a line going downward. The y-intercept is, you may be thinking 9. It is positive 9. Now you can just write 9, or you can write plus 9, which is positive 9. And finally, is it proportional? No. Why not? It's because you have that y-intercept. If the y-intercept is not 0, then it's not proportional. Slope right here is what's multiplied by x. It's this right here, 3/4. What's our y-intercept? You may be thinking it's 8, but no. It is in fact negative 8. Proportional? Again, no, because it's got a y-intercept. Number 3, our slope is what's being multiplied with x. That's 1.25. Our y-intercept is, is there a number that we're adding or subtracting to this? No, there is not. So we would say our y-intercept is 0. Is it proportional? Yes, it is, because it has the y-intercept is 0. All right, last question. Caroline's going to the state fair with a group of friends. It costs $12 for admission, so 12 for admission. And once she's inside the fair, she can buy tickets for 75 cents each in order to play games and purchase food or go on rides. In the equation, or write an equation to represent the relationship between the total cost, y, and the amount of tickets she buys. Okay, so in this example, she pays $12 admission and then 75 cents for each game or each ticket. So that's like plus 0.75 x. Okay, and they say, hey, the total cost she spends at the fair is y. So we would say y equals the total cost she spends is $12 plus the 75 cents per ticket. Remember, you always multiply the rate of change or slope with the x variable. A lot of times it's actually preferred that you start with the x, so y equals mx plus c. That means y equals m, the slope is 0.75x, plus b, the y-intercept, the constant, is 12. So they prefer you to write your equation that way. Anyways, what is the slope or rate of change? It is the 0.75, or 75 cents in this case. And what's a y-intercept? It's the $12 initially, because you don't pay more the longer you stay. It's just a one-time fee. And finally, describe what a graph of this relationship would look like. Well, it does have a y-intercept at 12, so basically you just imagine we have all this going up to 12. You'd have a y-intercept at 12. Now, 0.75, she's going to be spending more, like the more tickets she buys, the more she spends, right? So if the y-axis, this is like 1 ticket, 2 tickets, 3 tickets, 4 tickets, 5 tickets, what happens with how much she spends as she buys more tickets? It gradually goes up, right? So we should expect a positive slope. So line going upward, in line with positive slope, and y-intercept at 12. That's it. So those are non-proportional relationships. Again, the big difference between proportional and non-proportional is that if you look at a graph, proportional relationships, they are straight lines, and they start at the origin, 0, 0. If you have a table or you have points, you basically do y over x, and you check to see if all the y over x's, when you do y over x, if it's all the same, the ratio is the same, that means it's proportional. If you have a different ratio with different sets of points, that means it is not proportional. And finally, with the equation, it's similar to the proportion one, which is y equals mx, except this is y equals mx plus b. So we just have to add that y-intercept. All right, so hopefully you know enough to start on some practice problems. Good luck.